Hey guys, welcome back to BioSTEM Academy. In this video, we will continue from where we stopped in our previous video in econometric course for 500 level Agricultural Economics and Extension students. And this second video will focus on regression. So, what is regression? Regression presents an equation for estimating the amount of change in the value of one variable associated with a unique change in the value of another variable. Regression is concerned with the study of the dependence of one variable called the dependent variable, and dependent variable is usually denoted by y on one or more other variable, which is x independent variable. So the word regression was first introduced by Francis Galton. Francis Galton is the first person to introduce regression. And then another simple definition of regression is used for estimation, prediction, and forecasting. Regression is used for estimation, prediction, and forecasting. Regression is a measure of cause and effect. Regression is a measure of cause and effect. So, in econometrics, the regression equation in econometrics is y is equal to a plus bx plus e. This is regression equation, right? And where this is dependent variable, this e is error term, x independent variable, b slope coefficient, and a intercept or constant. Yes, definitely we've explained this in our previous video. And now, whenever regression model is being run on a computer, whenever we run a regression model, we expect at least 7 statistics. The basic statistic that we expect after a regression has been run are 7 statistics. These statistics are A, B, T, R, we have R squared, we have SE, and then we have F. 1, 2, 3, 4, 5, 6, 7 statistics. At least these are the 7 statistics that we expect at the end or as output of any regression model, be it simple linear regression model or multiple linear regression model. Now, what is A? A is constant, right? A is constant or intercept. A is also the predicted value of y when the value of x is 0. Predicted value of y when the value of x is 0. From the regression equation, y is equal to a plus bx plus e. A is constant or intercept. A is also the predicted value of y when the value of x is 0. For example, if x, our independent variable in a simple linear regression model, let's say x is 0. When x is 0, if talking about yield, for instance, as dependent variable, while this is fertilizer, yield per hectare, then fertilizer in kilogram. So when there is no fertilizer, that is when x is 0, when our independent variable is 0, then this is the predicted value of y, which is our a constant. For instance, y is equal to a plus b, but fertilizer is 0. Then substitute it with 0, and then when this is unexplained, which is error termed, then y is equal to a plus b times 0 is 0, and a plus 0 is a. So y is equal to a. So a intercept or constant is the predicted value of y when the value of x is 0. When you assume that you didn't take any of your independent variables, in case of multiple linear regression model, for instance, you have fertilizer, irrigation, farmer experience, years of farming, that is of farmer experience, household size, farm size, all those socioeconomic characteristics, they are also variables, independent variables. So when all of them are 0, the value or the predicted value of y, which is our dependent variable, is what is called a, and this a is intercept. So this is how you get your a, the explanation. I think this is clear. Now next is b. B is the slope coefficient. B is dy dx. B is the slope coefficient, the amount by which the dependent variable changes as a result of change in the independent variable. B measures the amount by which the dependent variable changes as the result of change in the independent variable. So B is dy dx, or B is amount of change we will predict in y for a 1 unit change in x. Amount of change we will predict in y for a 1 unit change in x. This is the simplest explanation on B. Amount of change we will predict in y for a 1 unit change in x. Now we're done with this. T value is the level of significance of the influence of the independent variable on independent variable. T, level of significance of the influence of the independent variable on the dependent variable. Now next is R. R is correlation coefficient. R measures the level of association between independent variable and dependent variable, level of association between x and y, how x and y are related. Then next is R squared. R squared is coefficient of determination. It is usually given in it ranges between 0 to 1. R squared value ranges between 0 to 1. It determines the amount of changes caused by the independent variable on the dependent variable. Amount of changes caused by the independent variable on the dependent variable. This is R squared, coefficient of determination. R squared value, at the end of the day, if you run irrigation, your R squared value may be 0.52. That means 52% of the variation in your independent variable are caused by contributed to your dependent variable. If it is 0.52, you know, of course, it's 52%. If it is 0.82, you know, 82%. And the percentage depends, the percentage tells you, you know, the gravity or the extent to which, you know, your independent variable contributes to the dependent variable. If it is 0.52, you know, it is of course, you know, half, 50% or 52%. If it is 80%, you know, 80%. If it is 0.80, that is 80% of the variation in independent variable contributed or caused by the dependent variable. I hope that is clear. Now, standard error. And before we move to standard error, R squared is always positive. R squared can never be negative. R squared is always positive, but however, B can be negative. B can be negative. Slope coefficient can be negative. A negative B indicates that as x increases, y decreases. As the independent variable increases, the dependent variable decreases. Why? Because of negative what? B, slope coefficient. Now, standard error of the estimate. Standard error, SE. Standard error It's a measure of precision of the estimate from the original. It's a measure of precision of the estimate from the original, either close to the actual value or away from it. That is your standard error. Now the last one, last output or last statistic in regression is F value. F value. F value measures the level of significance of the entire model. It measures the level of significance of the entire model. It measures whether the model is significant, whether the whole model is significant. Now, having understood regression, definition of regression, who introduced regression, and the 7 statistics in regression outputs, then let's move to OLS. OLS stands for ordinary least squares. Ordinary least squares. Ordinary least squares. So OLS, the OLS is just the act or the process of estimating the summation of E squares. OLS is all about calculating the summation of what? E squared. There's an OLS criterion. There's an OLS criterion which says that for any given data, the simple regression equation can be such that summation E squared equal to summation yi minus y cap all squared. This is the OLS criterion. We said that summation E squared equal to summation yi minus y cap all squared. Where did they get this? Let's try it. Regression equation is y is equal to a plus bx, right? Plus e. This is the regression equation. Then the y cap is equal to a plus bx. This is what? This is the estimation equation. Estimation equation. So from here we have your yi is equal to, instead of it write a plus bx, now come and substitute it with what? Y cap. Since this estimation equation has no e, it has no errata, then instead of it write a plus bx, just substitute it with what? Y cap. Y cap plus e. Now from here, let's make e subject of the formula. Making e subject of the formula from our basic change of subject formula or substitution, we say that yi is equal to y cap plus e. Then yi, this y cap will move to the other side, left hand side of the equation, minus y cap is equal to what? E. Therefore, it is the same thing as e is equal to yi minus what? Y cap. Now from here, introduce what? Or let's say square both sides. You square both sides, then square both sides and introduce sigma sign, that is summation, to both sides of the equation. First, let's square both sides. E squared is equal to yi squared minus y cap squared, right? You've squared both sides. Now let's introduce sigma, this sign, summation sign, to both sides. Summation E squared, right, is equal to summation yi squared minus summation yi minus summation y cap, all then squared outside because this square affects yi and it affects y cap, right? So this one is the same thing as this, right? This is the same thing as the summation E squared is equal to summation yi minus y cap all squared, and the same thing as summation E squared is equal to summation yi minus y cap all squared. So this is all about what? Ordinary least squares. How do you estimate your summation of E squared? It gives, and the aim is to get the sum of E squared. Summation of what? E squared is all about. OLS is to ascertain, the summation of E squared. And the OLS principle is based on Gauss-Markov theorem, which states that the LSQ estimate possess some desirable statistical properties. That is, the estimate are unbiased linear estimate, and they have a random variance. And the estimates, among the properties of OLS, we have what is called blue best linear unbiased estimator. Best linear unbiased what? Estimator. Best linear unbiased estimator. Now, having seen OLS, now how do you prove? Sometimes in econometrics we'll be asked, or we might be asked to prove that total sum of squares is equal to regression sum of squares plus sum of squared error, right? Total sum of squares equal to regression sum of squares plus sum of square error. Now, if you want to prove, or if you want to solve this question, let's say this is a question. Prove that total sum of squares is equal to regression sum of squares plus sum of square error. First, remember our regression equation: y is equal to a plus bx plus e. This is equation 1, right? Equation 1 is our normal regression equation. Then estimation equation y cap is equal to a plus bx. This is equation 2. Estimation equation has no error. That is the difference. And estimation equation has cap. This is cap. It has carried as cap, and then it has no error, right? So now yi, this is yi is equal to, instead of us to write a plus bx, since y cap is the same thing as a plus bx, now let's substitute it with y cap. A plus bx will be substituted with what? Y cap. Why? Because y cap is equal to a plus bx. So y cap plus what? E. Hope you've understood. yi is equal to y cap plus e, and the same thing as yi is equal to a plus bx plus e, because a plus bx is y cap. Now this is equation what? Equation 3. Now here is the next step is to square both sides and then introduce sigma sign, this sign, to both sides of the equation. Now first of all, let's square both sides. If you square this, yi squared, right, is equal to y cap squared plus e squared. We've squared both sides, both left hand side and right hand side of this equation. Equation 3. Now after squaring both sides, and we now move to introducing sigma to both sides. Introduce sigma, then summation yi squared is equal to summation y cap squared plus summation e squared, right? Summation yi squared is equal to summation y cap squared plus summation e squared. So now this is equation 4, and this is equation 5. Now from this our equation 5, we can say that this is the same thing as total sum of square is equal to this with cap is regression sum of square plus sum of square error. Are we together? Total sum of square equals regression sum of square plus sum of square error. Now from here we have proven, but we can still go further. Divide all through by TSS. What is TSS? Total sum of square. Therefore TSS is equal to RSS plus SSE. In other textbooks they write ESS, error sum of square or sum of square error. So anyone you choose. Total sum of square is equal to regression sum of square plus sum of square error. Now divide all through by TSS. Divide by TSS. All through by TSS by TSS. Right? Therefore TSS divided by TSS, it is 1 is equal to regression sum of square over total sum of square. We write it here, and then plus sum of square error all over total sum of square. That means if you are given your regression sum of square over total sum of square plus sum of square error over total sum of square, if you sum them together, you will definitely get 1 as your answer, right? But let's still go further. From here, 1 is equal to regression sum of square all over total sum of square plus sum of square error all over total sum of square. We can make this the subject of the formula. Make RSS all over TSS the subject of the formula. Why? Because 1 minus SSE over TSS will give us an important formula again. So how do you make this subject formula? Take this SSE over TSS to the left hand side of the equation. This is from our normal basic mathematics. 1 minus SSE over TSS. So 1 minus SSE over TSS. Why minus? Because this plus sign, after crossing the equality sign, will change from plus to minus. So 1 minus SSE over TSS. SSE over TSS is equal to what? In your right hand side you have RSS over TSS. In our right hand side we have RSS over TSS, right? So this is our coefficient of what? Determination. Coefficient of determination, where we said earlier that determines the amount of changes caused by the independent variable and independent variable. Show how much contribution of the independent variable on the dependent variable. For instance, if your R squared value is 0.46, that means 46% of the variation in the independent variable contributed to dependent variable, right? Only 46, which is low. Sometimes we get 50, sometimes we get 80, sometimes we get 80 something, but it will never exceed 1. It ranges from 0 to 1 and it's always what? Positive. So this is the same thing as your coefficient of variation, which in the regression statistic output is the same thing as R squared. So R squared has this formula, it has this formula again. If you have your SSE and then you are given your TSS, you can still go ahead and find your R squared, coefficient of determination. So at times, don't bother yourself, don't get confused or perplexed if R squared is not given while SSE and TSS are given. So if SSE and TSS are given, you can go ahead and find your R squared within this formula. R squared has this formula, 1 minus SSE over TSS. R squared also has this formula, RSS over TSS. So therefore, R squared is equal to 1 minus SSE over TSS is equal to RSS over TSS. So either ways, you can get your R squared, coefficient of determination in regression. And then you have what is known as another formula is B. So B, which is this slope coefficient or regression coefficient. B is your regression coefficient, while R is your correlation coefficient, right? So if you want to find the regression coefficient, the formula is B is equal to SP over SSX, where SP, sum of cross products, which is summation xy minus summation x summation y all over n, right? This is our SP. Then all over SSX, summation x squared minus summation x all squared over n. In case of what? Simple linear regression model. You are talking about simple linear regression model where you have only one variable, only single variable. For instance, y is equal to a plus bx plus e. This is a regression equation with only what? One independent variable. This is called simple linear regression. Why? Because it has only one independent variable. Just like in English, we have type of sentence. We have simple sentence, complex sentence, compound complex, etc. Why is this simple? He is a student. He is a student. This is a simple sentence. Why? Because it has only one verb. Why? Here you are saying that simple linear regression model. Why it is simple? Because we have only one independent variable as what? X. It may be fertilizer, and then this may be yields, this may be household size, this may be meat consumption or rice consumption in particular area or house. It may be bread consumption, it may be, this may be farm size, household size. If you say household size, for instance, household size, then meat consumption, dependent variable, independent variable, right? Dependent variable, independent variable, dependent variables. I hope you can be able to distinguish your dependent variable from independent variable. This is called regressant, and this is called what? Regressor, right? And I'm giving you variety of names for dependent and independent variables so that you cannot get confused. At times in exams, this confuses a lot of students. Unambiguous ambiguity of words. Independent variable is also called regressant. And dependent variable is also called regressant. Then independent variable is called regressor. It can be also called predictor, predictant, right? Predictor. This is predictor. This is explains. This is explanatory. All those are names of what? Dependent and independent variable. And then we also have another formula for R. This formula for R. So R, then R is equal to SP over root SSX dot SSY. What is SP? Sum of cross products. I've written the formula earlier. Summation xy minus summation x summation y all over n over square root of what? SSX. We know SSX. Formula for SSX is summation x squared minus summation x all squared all over n, right? Then after computing this, we get something here. Then we write it maybe 16, for instance, and then dot means times SXY summation y squared minus summation y all squared all over n and maybe here you get 3 after computing summation y squared minus summation y all squared all over n, maybe 3, and 16 times 3 is 48, for instance. Then what you get here divided by this will give you your r, and this r is correlation coefficient. Correlation coefficient measures the level of association, how x and y are related. Then how do you get your a? Which formula do you use to get a? You know that y bar is equal to a plus bx bar, right? Y bar is equal to a plus bx bar. This y bar, from y bar, if you in regression, if you are using simple linear regression model, you may be given question like it says y. This is x, for instance. This we are given xy, and then here let it be x squared y squared xy, right? Then here let's say we are given 2, 5, 8, 7, 3, and here 3, 6, 8, 9, 6, for instance. This is just a mere example. So here is your x. If you want to find your x bar, it is 2 plus 5, 7 plus 8, 15 plus 7, 22 plus 3, 25, right? So x bar, this is your summation x. X bar is equal to 25 over 1, 2, 3, 4, 5. 25 divided by 5. The answer is what? 5. So our x bar is 5. Here 3 plus 6, 9 plus 8, 17 plus 9, 26 plus 6. 26 plus 6 is what? 32. So our y is equal to 32. But y bar is equal to 32 over 1, 2, 3, 4, 5. And then 32 divided by 5, I think it's going to be 6.4. If I'm not mistaken, I think 6.4, right? So this 6.4 is our y bar. So from here, you get your y bar. And here, if you square your x, you get 4. If you square your 5, you get what? 25. You square 8, 64. You square 7, 49. You square 3, you get what? 9. Here, y squared. If you square y, you get, the first one is 9, 6 squared 36, s squared 64, and then 9 squared 81, and 6 squared what? 36. xy, 2 times 3, 6. 2 times 6, 30. xy, 8 times 4, 30. 8 times x, 64, right? 7 times 9, this is 3. And then 3 times 6 is 12. 18, sorry. 3 times 6 is 18. So this is how you get the remaining fields. You fill the remaining tables. Remember, you will only be given x and y. X squared, y squared, xy. You either want to bring them yourself, and then you get them. They're simple as this. X squared, just square this, y squared, square your y, xy, multiply them. Not x plus y please. Xy means what? Multiplication. Then from here, y bar is equal to a plus b x bar. So from this question, y bar is 6.4, right? Y bar is 6.4 as calculated above. 6.4 is equal to a plus b, and x bar is what? 5. Then write 5 here, right? Let's assume we've used this formula. We've used this formula. B is equal to sp over ssx, and then we got something like 0.6, right? As our what? As our regression coefficient or slope coefficient, okay? 0.6. So comma substitute it here. 6.4 is equal to a plus 0.6 times 5. 6.4 is equal to a plus 0.6 times 5 is going to be 3.0, right? So from here, y bar is equal to a plus bx bar. 6.4 is equal to a plus b into 5. 6.4 is equal to a plus b. It is assumed it is because I don't want the video to be too longer. Now it is long, I know, but I don't want it to be too longer. Maybe I'll prepare a regression example solved. I will solve it. I will show you how to get y, how to get y bar, x bar, a, all these 7 statistics manually. What? Manually. Why? Because we are using simple linear regression model. Manually you can compute, but if you are using, multiple regression model where you have more than one variable, like 10 variables, this is something, labor intensive, time consuming, it's very hard, it consumed most of your time, and it is confusing. You cannot compute it. Sorry to say, I'm not saying you will never compute it, but it's of course a big deal for you to compute multiple regression model manually like this. But simple regression model, very easy. Why? Because it has simple, only one independent variable, like this, only one independent variable. So how do you get your A? A is equal to 6.4 minus 3. That's how you get this, which is 3.4. This is how you get your A. So you can ascertain your A from y bar is equal to a plus bx bar, right? Can ascertain your A from y bar is equal to a plus bx bar. But in the situation where you have y is equal to a plus b1 x1 plus b2 x2 plus b3 x3 dot plus bn xn, please never use manual methods like this in computing this, this one, this and this. Why? Because it is very difficult. So use statistical softwares like SPSS, statistical package for social science. I know this is common to you since 300 level. We all know this, from our statistics and data processing, or from application of computer to agriculture. You were taught this SPSS. There are stages, there are steps in getting this. Even this one, you can get it within seconds. SPSS can compute this, but for example purpose and for you as an agri-economics, to prove yourself that definitely, yes, of course, you know what you're doing and you know what you're studying. This is extremely important for you to know. SPSS, Starter, eView, R, all those are packages, or they are, software for social science and, agriculture particularly. So this, we come to the end of this video. In the next video we will continue from where we stop, inshallah. And again let me emphasize and reiterate myself more. Let me emphasize and reiterate myself more on seven statistics. On the 7 statistics, let me re-emphasize more on these 7 statistics. You see them? A, B, T, R, R squared, S, E, F. They are extremely important. They are paramount. They are essential. They are indispensable. They are extremely important, paramount, essential, indispensable for you as agri-economics, and extension student. Not even agri-economics, even an animal scientist cannot understand, a course offered in 500 level second semester, livestock economics. Livestock economics, you have plenty of this. So without this, you cannot understand your livestock economics. So I'm advising you to make every endeavor to grab all this A, B, T, R, R squared, S, E, F. What do they mean? What do they stand for? And then apply them and relate them to real, economic problems. Example, real life problems like, irrigation farming, for instance. Everyone is conversant with irrigation farming. They are all familiar with it. So please, it is important that it is even imperative for you as agri-economics to know the explanation of A, explanation of B, T, R squared, SE, F value. Why? Because you can go no further without understanding these 7 statistics. I've explained them. If maybe I'm too fast, you can pause the video and then listen to the explanation of each parameter here. These are parameters to be estimated. You can pause the video. While watching the video, you can pause it and then jot down the explanation. So, and feel free to comment on the comment section where you stuck or where you need more clarification on any term that get you confused. Thank you and good evening.